Hi, welcome back. I'm Tammy and I do math for coffee. Today I'm teaching right triangle trigonometry. By the time we are done, you're going to be using sine, cosine, or tangent to find missing sides and angles, but bonus, you'll understand what you're doing. I'm going through the entire lesson, so I'll break this up into chapters down in the description. The first time you watch all the way through. When you're doing your homework, use the chapters to skip up to the examples. When you're reviewing for a test, watch the whole thing, but change the playback speed so it'll go a little faster. You ready? Let's do this. If you would like a set of guided notes that you can download, print, and fill in as you're watching this video, plus some extra practice problems just to make sure you really get it, check down in the description. I'll put a link down there for you. In any right triangle, one of the first things you want to do is identify the hypotenuse, and the hypotenuse is always the side across from the right angle. You can actually draw a little arrow from the corner of the right angle, and that's going to be your hypotenuse. It's always the longest side. That's never going to change. But there are a couple angles inside the triangle, and the other sides have names, but they are in relation to where you are on the triangle. That little symbol right here is for an angle. It's a variable. It looks like an O with a line across it. That's called theta. It's a Greek letter. We use that instead of like X or Y, just because it's an angle. So at this angle, this is going to be the opposite side across from the angle that you're at. And this is going to be the adjacent side. The adjacent side makes the angle with the hypotenuse. Now, things change a little bit when you change angles. So it's the same triangle, but now I'm up on the top angle. The hypotenuse is never going to change. That's always across from the right angle. But the opposite side now is down below, and the adjacent side is the one that's going up and down. So those two things are going to change depending on where you are standing on that triangle. This is how I explain it when I'm in a class. I'll actually go and stand in a corner and put my arms out, and if my head is in the angle, my hands are going to be touching two sides and not touching the third side. The sides I can touch are the hypotenuse and the adjacent side, and I will not be touching the opposite side. When these triangles spin around, this is a way you can remember how to tell which one is adjacent and which one is opposite. Now, sometimes when they turn the triangles upside down, so the right angle is up on the top, that can feel a little tricky. Still go for the hypotenuse first. That's always across from the corner. The opposite side then is the one that's farthest away from the angle, and the adjacent side is touching the angle. These are the abbreviations for opposite, hypotenuse, and adjacent, and I'll be using those primarily for the rest of this video because there's only 3 letters, and I'm a math teacher, which means I don't like writing out full words if I can get away with it. Jumping over here on my computer, I have built a triangle that I can move around a little bit, and I want to show you something about the relationship between the opposite side, the hypotenuse, and the adjacent side when you set it up into ratios, and then change the side lengths and see what happens. So first off, let's look at what happens when you divide the opposite side by the hypotenuse. Now, watch what happens to the ratio. Right now it's 0.65. But if I leave the angle the same and don't change it and just change the size of the triangle, it's much smaller, but look at the ratio. It's still 0.65 when you divide the opposite side by the hypotenuse. Same thing is true if I make it really big, and even if I change the orientation, that 40-degree angle is still the acute angle at C. The side lengths change. That ratio does not change. Let's check the adjacent divided by the hypotenuse and the opposite divided by the adjacent. Look at these numbers, 0.65, 0.76, and 0.85. Pay attention to those as I change the side lengths. All the side lengths are moving, the 40 degree stays the same, and that ratio stays the same. The only way these are going to change is if I change that acute angle at C. And I'm going to do that right now. Let's just pick a different angle. I don't know. You want to go bigger? Let's do that. Let's change it to 55. Now here are the ratios, here are the side lengths. What happens when I change the side lengths now? triangle is smaller, that's still an acute angle. It's 55. Even though it's typed over here, you guys, I'm sure you're with me on this. The ratios do not change. Even if I make this thing hecka big and go off the screen, the ratios do not change. Well, the thing about these ratios is I just showed you they don't change. The only time the ratios change is if the angles change, not if the side lengths change. So this makes them constant. It means they can be programmed into your calculator. Back in the day, we used to have to, I'm sorry, this is my I walked 3 miles to school in the snow story. Not really. It's just that when I was in high school, we didn't have calculators. And so when we were learning how to do right triangle trig, we had to go to a table in the back of the book. So we would just look them up. I'm not going to go into it too far, but I just wanted to give you a visual as to why your calculator has these for you, because they're programmed in. They don't change. One of them is the sine ratio. The ratio for the sine of theta is going to be the opposite side divided by the hypotenuse. From the demonstration, you saw that those stay the same even if the side lengths change. When you take the adjacent side and divide it by the hypotenuse, we call that cosine of theta. And the opposite side divided by the adjacent side is called tangent of theta. Now, to help you remember all these, there's an acronym that a lot of people use, and it is SOHCAHTOA. So, that is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Let's come up with some ratios here. When you're first learning these, this will be the first kind of problem they ask you to do. They don't give you any angles, they just give you side lengths, and you are supposed to figure out what the different ratios are going to be based on the angle that they give you. Now here in this situation, J and K, they're vertices, but they're also referring to the angles in those corners. So let's fill all these in. Let's start with J. So you are standing here in this corner. That's your hypotenuse because it's across from the right angle. This is your opposite side, and this is your adjacent side. So for sine, remember SOHCAHTOA. And I usually just write that down onto the top of every paper that I'm working with. Sine is opposite over hypotenuse. So this would be 16 over 34. Normally you would reduce that, but just to make this move along a little quicker, I'm not going to do that part. We just need to pick the right numbers. Cosine is adjacent over hypotenuse, so that's going to be the 30 over the 34. And tangent is opposite over adjacent, so that's going to be the 16 over 30. Let's move over to the other angle. Now we are at K. So things change. The hypotenuse doesn't, but we take that off, we take that off, we take that off. So if you are standing at K, this is now your opposite side, and this is now your adjacent side. So the sine opposite over hypotenuse is now going to be 30 over 34. The cosine is going to be adjacent over hypotenuse, which is now 16 over 34. And tangent is going to be opposite over adjacent, which is 30 over 16. Now, if you compare, this is the same triangle. We were just standing in different corners. But look at these numbers. The sine of J ends up becoming the cosine of K. Interesting, huh? The cosine of J is the sine of K, because you only have 3 numbers to work with, so it's just different combinations of them, but it's because the opposite and adjacent flip around. But then when you look at the tangent, they're the same numbers, they're just reciprocals of each other. You try this one, and I'll be right back and show you the answers. If we start with B, we are standing right here. This is your opposite side. This is your adjacent side. The hypotenuse is always across from the right angle. This triangle is the one I said that was a little tricky because when they get turned upside down, sometimes that can throw people off. Sine is opposite over hypotenuse, so this is going to be 8 over 17. Cosine is adjacent over hypotenuse, so this is going to be 15 over 17. And tangent is opposite over adjacent, so that's going to be 8 over 15. Switching to the other angle in this triangle, which is C over here. Making some adjustments because the opposite and adjacent are going to change. Hypotenuse stays the same, but now 15 is the opposite side and 8 is the adjacent side. Sine is going to be 15 over 17. Cosine is going to be 8 over 17. And tangent is going to be 15 over 8. How'd you do? I'm going to do something that you don't usually see teachers do, and that is why we don't do trig ratios from the right angle. L is the right angle. So the ratio for sine is opposite over hypotenuse, but here's the thing, the opposite side and the hypotenuse are actually the same number, and it's always going to be the same number, so that ends up becoming 1. Nothing terribly wrong with that, but then cosine is adjacent over hypotenuse. So here's the problem. What side are you going to use for your adjacent side? And tangent is opposite over adjacent, and you end up having the same problem. So as far as geometry goes, right triangle trig, we never do it off of the 90-degree angle just because there's confusion. For this problem, we are asked to find a missing side, and so we're going to use what we know about the trig ratios to set up an equation and solve for x, that missing side. We are given the angle. We know that the angle is 34 degrees. Now, from 34 degrees, let's identify the sides that we have. We know the hypotenuse is 28 because that is across from the right angle. And we know that this side that we're asked to find is the opposite side. The side that we're not asked to find or have it given information about is the adjacent side. In this particular situation, I don't need to work with the adjacent side. So you have to pick the right trig ratios. You have your SOHCAHTOA to help you remember what the ratios are. Use the trig ratio that uses opposite and hypotenuse, and that will be the sine ratio. So we write this out. The sine of 34 degrees equals opposite over hypotenuse. That's going to be x over 28. Now, before you touch a calculator, I want you to do these problems as far as you can without figuring out what the sine of 34 degrees is, because most teachers are going to give you credit even if you don't completely finish it. Let me show you what I'm talking about. When you are going to solve this, it's actually a ratio. I could write it out, and this will be the only time I write it out like this because it just takes time, but I want you to see what I'm thinking. Put the sine of 34 over 1, and then you have x over 28, and now you have a ratio equal to a ratio, and we solve proportions by cross multiplying. X times 1 is x, and that equals 28 times the sine of 34 degrees. If you don't have a calculator handy, this is an actual answer. This is correct, and most teachers are going to give you full credit for writing it out like that. But this also allows us to go to the calculator and enter it in one step. With your regular scientific calculators, that's going to work. You don't need to figure out what the sine of 34 degrees is. You can let the calculator do that for you. Now I'm going to use the computer calculator, which means I can't enter it exactly how you would use it in the calculator you have right now. You could probably just type all of this in. 28 sine 34, enter, boom, answer. For me, I'm going to have to put it in a little differently because the syntax issue, just because of how this works. So that's sine of 34 degrees, you get this big long decimal, which you don't want to write that down ever. We're going to multiply that times 28. And that is 15.657. I'm going to round it to 3 decimal places. Read the directions and follow what it says for your directions, but I like to always go to 3 decimal places because if I round incorrectly on the last one, I know the first 2 are right. So this is 657. The hypotenuse is 28, so it makes sense that the answer has to be less than 28 since the hypotenuse is the longest angle. For this one, if you think you know how to do it, pause the video and try. I am about to do it. And then you can come back and check and see if you got the same thing I did. All right, I'm going to start by giving myself my little helpers here. And now I need to label the triangle. I am looking for x, which is right here, and I'm given the 50-degree angle, and I am given the hypotenuse. And x in relation to this 50-degree angle is the adjacent side. I don't have the opposite side, and I'm not asked to look for the opposite side, so I don't need that O at all. So the thing I am going to use is adjacent and hypotenuse, and that's going to be cosine. The setup is that the cosine of 50 degrees equals adjacent over hypotenuse. I was talking about cross multiplication, but you can also think of this as clearing the fraction. Think of it that way. When you multiply both sides by 80, the 80 is going to cancel on that side. So we have x equal to 80 times the cosine of 50 degrees. If you're using your phone, it'll still work. You just have to know how to put it in. So we're going to start with the cosine of 50. So I type in 50, get the cosine, and I get this really long decimal. While that's still in the calculator, I am going to multiply that times 80. And that's our answer, 51.423. If your problems have units of measurement like miles or inches or centimeters or whatever, make sure you use your units. I'm not putting units on here because we're just learning how to do this skill. We are given the 23-degree angle here. The side opposite the right angle is not given. That's my x, and I know that is the hypotenuse. This is the opposite side. Once again, they're not giving me the adjacent side, so I'm going to use sine again. Sine of 23 degrees equals opposite over hypotenuse. This one's a little different. When the x is in the denominator, that is another tricky little question, which is why I included it for the video. We are still going to cross multiply, but this one's going to take an extra step. You'll see what I mean here in a second. So we end up with x times the sine of 23 degrees equals 16. So we're cleared all the fractions, but now we have another problem. The x, if you're going to solve for it, now we have to divide. We're going to divide both sides by the sine of 23 degrees. Now we're going to go to the calculator and we're going to do 16 divided by the sine of 23 degrees. I'm going to do it on my calculator, you do it on yours. But again, syntax errors can come up here. Some calculators may want you to put parentheses around the sine of 23 degrees. Let's see what happens with my clunker here. All right, so I know I'm going to do 16 divided by, and for sure I have to use parentheses because I have to enter this kind of strangely. 23 has to go in first and then the sine, and then I'm going to close that parentheses and hope for the best. And I got an answer. Cool. Did you get 40.9489? Because that's what I got. If I made a mistake there, will you guys let me know in the comments? This problem is a little bit different. Now we're going to find a missing angle. You need to use the trig functions, but you're going to use them in reverse. Remember how I said that all of these angles and their trig values are stored in the calculator? We have to get the calculator to give that back to us. So you use your inverse functions. And if you look on your calculator, you'll be able to see it right now. You probably have to use the Alt button or something, but there should be a sine to the -1, cosine -1, tangent -1. Those -1s are not exponents. That means inverse. Or in real language terms, it means reverse. You're going backwards. So we start the same way. This is the angle that we're looking for. The 9 is the hypotenuse. The opposite side, I'm not given. I have no data there, and I'm not asked to find it, so I ignore it. The 7 is the adjacent side. Think about your trig ratios. SOHCAHTOA, which one uses adjacent and hypotenuse? That is cosine. All right, so if we wrote this out the way we have been doing it, we would write something like the cosine of theta, the angle we don't know, equals adjacent over hypotenuse, which would be 7/9. Now, if you want to get the calculator to dig into its memory and tell you what that angle is based on the 7/9 information, you're going to theta equals the inverse cosine of 7/9. And this is really what you're going to plug into the calculator as well. This is going to have the calculator return what the angle is. Let me pull over my computer calculator and see how I'm going to make this work. I need to use parentheses on this because I want the calculator to actually calculate that out for me first. You don't need to. If you're using a regular scientific calculator, your syntax is probably going to be just to type in the inverse cosine. I'm going to go second. See how they pop up here? This is the one I want. And there it is, 38.942. So my angle is, theta is 38.942 degrees. That's probably too many decimals for an angle. Check your directions. They usually want maybe 1 decimal or even round it to the nearest one. And just for fun, let's check and see. Let's say I put that in and just find the cosine of it. Let's figure what 7 divided by 9 was that. Just a bunch of 7s repeating, right? What I'm going to do is find the cosine of this angle and just to check my work and see if that actually worked out. 38.942. And let's do cosine of that. And it's pretty close and doesn't even change until you get to like the 5th decimal place. And remember, we rounded this off, so that's why that's happening. So remember, all this stuff's stored in there and you just need to have the calculator find it for you. If you want to try it yourself, pause. Otherwise, I'm forging ahead. As usual, I write down my little helpers, SOHCAHTOA. Go in and label my triangle. I am given this angle. I do know that the hypotenuse is directly across from here. This is the opposite side from theta, and 32 is the adjacent side. I'm not asked to find the hypotenuse, and I'm not given any information about the hypotenuse. It's not going to be used. Go in and look at what we have. We have opposite and adjacent, so we are going to use tangent. It's really easy to start calling it TOA, but remember, it's actually tangent. The tangent of theta is opposite over adjacent. Now, in order to be able to go backwards to find the angle, the function we're going to use is the inverse tangent. That would be 51 over 32. Now, depending on the calculator you're using, you're going to just put in the function, get the parentheses, then there's 51 divided by 32, close the parentheses, hit enter, and that'll be your answer. But since I am using my computer calculator for the video, this again is like how you would do it on your phone. We're going to get the 51 divided by 32 first, so we know what the decimal is. And I mean, you can write that down, but I'm going to not write that down. I know I want to apply the inverse function, so I will hit second, and then all of these change. That'll happen on your phone too. Look for that little second button, and then inverse tangent. And there's our angle. Okay, 57.894 degrees. When they say solve the triangle, they want you to find everything you don't already know. You can use trig, you can use triangle sum theorem, you can use Pythagorean theorem. You have a lot of tools in your toolbox right now. We just jump in and do it however you want to do it for the most part. One of the things I can do right off the bat is find this other angle. So I know that that's 90 degrees, and I know we have a 24-degree angle. The other angle is going to be triangle sum theorem, and I know you can do this a little faster, but I'm going to just make the point. We haven't done one of these in a long time. We're going to subtract the 90, and then we're going to subtract the 24. Remember, all the angles inside of a triangle add up to 180. That other corner has to be 66 degrees right here. That's part of solving the triangle. Now we need to find the missing sides. You can decide which angle you're going to stand at, but just a tip, always use the numbers that were given to you instead of something that you calculated, because then if you made a mistake calculating something, everything you use later on is going to be wrong. So if I'm going to use this 24 degrees, the 14 is the hypotenuse, and I need to find one of the other sides, and it doesn't matter which one I want to go for here because I don't know either one. I'm going to go ahead and go for the opposite side, and I'm going to put an X here. So the sine of 24 degrees equals opposite over hypotenuse. Now remember, there's a 1 underneath the sine of 24, and you cross multiply. X times 1 is x, and that equals 14 times the sine of 24 degrees. Run that through in the calculator, and we're going to get a side length. And remember, you're going to enter it on your calculator differently than I'm doing it on the computer calculator, but if you're using a computer calculator, this is how we do it. Find the sine of 24 degrees first, and then take that answer times 14. 5.694. All right, so I know this side. Now at this point, you know two sides. You could use Pythagorean theorem to try to find the other side, but I'm going to use trig because that's what I'm teaching, and I think it's more fun. So I'm going to call this side y. From the 24-degree angle, that's an adjacent side. So now we're going to switch to cosine. The cosine of 24 degrees equals adjacent over hypotenuse. That's my y over 14. Same maneuver. Y equals 14. Cosine 24 degrees. Bring the calculator back. Clear that information. 24 cosine. Multiply that times 14, and there's our answer, 12.789, but the 6 bumps the 9 up, which bumps the 8 up to 9. So what is that going to be? 12.790. Now we know this side, 12.79. You now know all three sides and all three angles, and that triangle is now completely solved. All right, now we have to take a look at another problem you're going to see in this section, and that is an application problem having to do with angle of elevation. The idea here is, how tall is this really tall thing that we can't measure directly? So somebody's going to go out and they're going to stand on the ground, and they are going to use a device to figure out the angle of elevation from where they are standing up to the top of the very tall thing. If it's a surveyor, they use a device called a transit to find the angle of elevation. We're looking at a problem here where a surveyor has actually measured the angle of elevation from where she's standing to the top of the building to be 22 degrees. Now the thing is you have to make an adaptation. You have to adjust because the transit is not right on the ground. So the right triangle is not starting from the very bottom of the building. It's actually starting, in this case, 5 feet up. We're going to solve for the height of that building, which will be my x right here. But it won't be the entire height because you get this 5 feet that you'll have to add on at the end to make the adjustment for the stand. We do the same thing. These are all triangle problems. No matter how complicated the word problem sounds, if you are doing right triangle trig, this is going to be a right triangle, and you need to figure out what you are given and what it is that you are looking for. So you are standing here, it's 22 degrees. You are asked to find the height, which is this x. I know that this is the opposite side. On the bottom, it was 300 feet from the building to where she set up the stand, and this is the adjacent side. What you don't know is the hypotenuse, and for real life problems, you're probably not going to know the hypotenuse very often because we can measure the horizontal very easily. So let's set this up. Which trig ratio uses opposite and adjacent? That's tangent. So the tangent of 22 degrees equals the opposite over the adjacent. And now all of a sudden it's a problem just like we were doing before. We're going to put that tangent over 1, do the cross multiplication. You get x equals 300 times tangent of 22 degrees. Now if you don't have a calculator, you're going to get full credit for that, I think. I'm not your teacher, but every teacher I know is given full credit for that because that's actually a really good answer. You make a mistake after that, it's really hard to figure it out. But right now I can tell a student who wrote 300 tangent 22 degrees, they know what they're doing. They use the right trig ratio, they use the right numbers, everything's in the right spot. When I was teaching, I preferred people didn't go all the way to the final answer, but that's okay. So we got the tangent of 22 degrees is a big long decimal that I don't want to write down, so I'm going to take that answer and just multiply it times 300. And that is the height of the building. Sort of. It is x for sure though, so that's 121.208. Now, if this is your final answer, you're going to lose a point. because remember, that doesn't include the 5 feet that we have to add on. The X is accurate, the math is accurate, but the actual building is 5 feet taller because we didn't start at the ground. 126.208 feet tall.